Hello Year 7. Today's lesson we're doing about chemical formulas. I'm going to open up my periodic table because it's going to be useful. I'm going to go to View, Rotate clockwise. So let's put that minimized. So chemical formulas, we will start with the PowerPoint. So there it is. So, first part of today. What does this mean? Write everything. Well, hopefully we know that H and O are different elements. Hopefully we know what the numbers mean as well. So let's start. H, well, this is an element called hydrogen. O, this is an element called oxygen. And you could find that on your periodic table. Now this big 2 here, that means I have got 2 of these. So this whole molecule is called water, H2O. This is a water molecule, and that means I've got 2 of them. I've got 2 times H2O. 2 times that. Well, what does this little letter mean? Because it comes directly after the H, that means that I've got 2 H's. So H2 equals, well, I've got a H and a H, right? So if I was to draw every element that I've got, every atom, sorry, I've got a H, I've got a H, and I've got an O. They are the 3 atoms that are present in water. Right, let's continue. So pause it if you'd like to read the lesson objectives. Now, we do remember this from before, we've covered it, but just as a little recap, an element always starts with a capital letter. Okay, so an element always has a capital letter. So here, silicon has a capital S. Capital S, capital I is not silicon. Okay? You should know capital S from your periodic table. If you go and have a look, will just be sulfur, and capital I will be iodine. So if you wrote this, that would mean something completely different to this. So you have to be very careful with that. So again, aluminium is that capital A, capital L doesn't actually mean anything on the periodic table. So it's not correct. So you'll have to pause to have a go at this. But I'd like you to try and use your periodic... I'll say that again. I'd like you to try and use your periodic table to list the different elements in these compounds. You have to write their names. So, using them, I'm going to do number 1 for you. Using my periodic table, I know that this equals silicon. And I know that this equals oxygen. Oh, oxygen. So I would like you to do the same for 2, 3, 4, and 5. Which elements are present in this? Now I know that this is one element because it was a capital letter followed by a lowercase letter, and I know this was a new element because it was a new capital letter. So have a go at them. So I'm assuming that you paused the video, you've written your answers, and now you've unpaused it again. So I'm going to quickly go over these. So here we go. This one, S equals sulfur. I is iodine. And O is oxygen. This one, Z, N equals zinc. Oh, that's an S, that's not a Z. Zinc. O we know is oxygen. H equals hydrogen. S equals sulfur, which we've done before. O equals oxygen, which we've done before. Fe equals iron. Now it doesn't matter that these are in brackets just yet, but you know that there is a capital O, so that must be oxygen, and a capital H, so that must be hydrogen. So let's move on. I can find it. There it is. Now, as I said before, Here is magnesium oxide, and it is MgO2. So MgO2. The subscript 2, that means it's a small 2 that's slightly below. Now, I'm just going to show you what you don't write. So this is correct. That is fine. This is wrong. Okay, you do not write that. You also don't write that. Okay, it has to be below and small. It's not like in maths, okay, that this is a superscript. That's x squared. We have a subscript, which is slightly below. Okay, so that is a subscript. This means that that's how many oxygens I have. Now the little 2, so I've got an element here, I've got magnesium, and I've got oxygen. The 2 only applies to the element that it goes after. Okay, so that little 2 only applies to the O. So that means I've got 1 magnesium atom, because really this would have a little 1 next to it, but we don't write 1s because it's a waste of effort. Just for example, if I had in maths, if you do x equals 5, you don't write 1 times x equals 5, you just write x. It's the same here. So we've got 1 magnesium atom and we've got 2 oxygen atoms. Okay. Now, let's have a look at chemical formula. You don't have whiteboards, but you can open Paint, or you can open any editing program, or you can just listen. Hydrogen dioxide or water, we know from before this has 2 atoms of hydrogen and 1 atom of oxygen. Okay. Or H2SO4. So if I get my pen, H2SO4, we should hopefully know that because the 2 is directly after this element, yeah, the 2 is directly after this element, I have 2 hydrogen atoms, so I've got 2 times hydrogen. This sulfur here, the S, doesn't have a number, so that means there's 1 sulfur, so I've got 1 sulfur atom. And if I look at the oxygen, which is the next element, I've got a number that follows the oxygen, which is a 4. So I know that my oxygen, I have 4 atoms. Okay, so I'm going to skip past where they pop up. Now, if I did that instead, and this instead, the big number represents something completely different. So the big number means that I have got 2 whole molecules. So here I've got 2 of these. So in total, if I've got 2 of these, if I had 1 of them, I had 2 hydrogens and 1 oxygen. If I've got 2 of them, I've got 4 hydrogens and 2 oxygens. The same here. I've got 4 of these. So you could actually just write this out 4 times, and that's what you've got. So, how many atoms are in this? Well, you should know there are 2 atoms, 2 oxygen atoms. This one, in total, there should be 3 atoms. Hopefully you know that there are 2 hydrogen atoms and 1 oxygen atom, so that makes 3. This one, well, that's an element, so that'd be 1 atom, copper. There's 1 atom, sulfur, and there are 4 oxygen atoms. So that's 4, 5, 6 atoms in total. This one, let's have a look. Well, we've got 2 hydrogen atoms, we've got 1 sulfur atom, and we've got 4 oxygen atoms. So that's 4, 5, 6, 7. So now, again, after I've explained this, I'd like you to pause it and have a go. I'll do the first one for you, and then I'd like you to do the rest. So I'll do the first one. So it says here, list the number of different elements in each of these compounds. Okay. And I would like you also to include the number of atoms of each element. So what do I mean by that? Well, let's have a look at this. I know that this one, and if you look from the previous task, they are the same. So you've already written the number of elements down somewhere. Okay, so if you've done the first task, you've already got this information, you can just add on to it. So somewhere you have got that this contains silicon and this contains oxygen. Okay, somewhere you've got this written down. Silicon, have I spelled that right? Anyway, well, I know from this here, I only have times one atom of it. Well, and from this, I should know that I have got 2 oxygen atoms. Times 2 atoms. So what I'd like you to do is pause the video and try and add to what you did before. How many atoms of each element are present in each of these questions? The last one, I'll give you a hint. It's a bit like in maths where you have to multiply out the brackets. So pause and have a go. So I'm assuming you've paused the video, you've completed this task, you've unpaused it now, and I'm going to go through them. So this one has sulfur from before, and it's got times 1 atom. We've got iodine, times 1 atom again, because if you look, there's the sulfur. This is a new capital letter, so it's a new element. Then the third capital letter is oxygen. And we have got times 2 atoms there. Well, let's have a look at the next one. Capital letter, lowercase letter. This is zinc. We've only got 1 atom. Oxygen is the next one. We've got 1 atom. Let's look at number 4. H2. Well, we know that's hydrogen. And we know that we've got 2 atoms because of the subscript, or the little 2 next to it. Sulfur doesn't have a number next to it, so that is a 1. So we've got sulfur, and we've got times 1 atom, and oxygen is there. And that little number means we've got times 4. So let's do the last one. Iron. That is iron. We've got times 1 atom. Now here, normally this would be oxygen times 1 and hydrogen times 1. But if you notice, they're in brackets and they've got a little 3 next to it. So this is basically multiplying everything in here by this number. Instead of writing O3H3, we write it like this. OH3. Just to save on writing. It's less writing. And also it's easier for you to understand that there are 3 of these inside this bracket. So we have oxygen times 3, and we've got hydrogen times 3. So that's that done. So let's move on. Here is a visual representation of magnesium oxide. Before, we worked out that we had 1 magnesium atom and we had 2 oxygen atoms. Okay, so there's magnesium. Because it's not got a number, it's got 1 magnesium atom, and here we've got 2 oxygen atoms, and this is what that molecule would look like. You'd have 1 magnesium attached to 2 oxygens. So that is drawing something using particle theory, and sometimes that might help you understand what it is you're looking at. So sometimes that helped me to understand the formulas, but just by drawing it out. Now, again, very quickly, I like to draw these out using particle theory. I'm going to do the first one again for you. So silicon and oxygen. You've got all your information from the last task, so you know exactly how many atoms of each there are because you've written them down. So you're not doing any more. You're not recalculating anything. You're just looking at the answers you've already done. So let's do. So there's my silicon atom, and there is an oxygen atom, and then there is the other oxygen atom. I'll do number 2 as well. Actually, I will do number, I'll do number 2. So this is number 2 over here. Here I've got a sulfur atom. I have got a iodine atom, and I've got 2 oxygen atoms. Now, for now, I don't mind how you draw them. You can draw them in a line like this, or you can draw them in a clump. Generally speaking, they'll be symmetrical. That doesn't matter. So as long as you understand that this is 1 silicon atom, 1 iodine atom, and 2 oxygen atoms. So draw that for the rest of them. Pause the video, and then I'll quickly finish them off. Okay, let's do the answers now. 3. You've got 1 zinc atom attached to 1 oxygen atom. 4. You have got 2 hydrogens attached to a sulfur, and then attached to 1, 2, 3, 4 oxygen atoms. Here below we've got 1 iron atom. Now this is attached to, well, we said before there were, if I was to, this would be 3, and then this would be 3, wouldn't it? So I have to do 1, 2, 3, 1, 2, 3. There's O, 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 H, H, H. There we go. 1 iron atom, 3 oxygens, 3 hydrogens. And for now, we're not worried about the structure. We're just focusing on drawing the particle theory. The extension there, I'll talk about that later. Okay. Let me discard this. Now, if I go to my periodic table, and then I'm going to open up the extension formula mass. If you found all of that really easy, okay, and you want something a bit more challenging, I'd like you to look here, right back at your periodic table, and notice that the top number says relative atomic mass. So here, beryllium has a relative atomic mass of 9. Let's have a look at carbon and oxygen. Carbon has a relative atomic mass of 12, and oxygen has a relative atomic mass of 16. So to calculate formula mass, which is a GCSE concept, let's say I had my carbon dioxide, atom, molecule, and if I'm just going to quickly draw it, remember I said a carbon dioxide, there'll be a carbon, there'll be an oxygen, and there is an oxygen. From my periodic table, I have just said that carbon has a mass of 12, and oxygen has a mass of 16. So now this has a relative mass of 16, this has a relative mass of 12, this has a relative mass of 16. So, what is the mass of just one full molecule of this? What is the mass of this whole thing? Well, what you do is you get the mass of each atom and add them together. And that is what's happening up here. We've got 1 carbon atom and we've got 2 oxygen atoms, which we've just shown. The carbon atom has a mass of 12. The oxygen has a mass of 16, but we have 2 of them. So what is the mass? Overall, 44. And if you did 16 plus 12 plus 16, that equals 44. So what we are saying is this molecule of carbon dioxide has a relative atomic mass of 44. That's the mass compared to hydrogen. So this is 44 times heavier than hydrogen. It's not quite that simple, but you learn about that in A-level. So if I was to do silicon dioxide, we'll discard the ink. Let's have a little look here. Well, we'll do silicon dioxide. SiO, let's get a color that you can actually see. There we go. SiO2. Silicon dioxide. From my periodic table, let's find silicon. There it is. Silicon has a mass of 28. Oxygen has a mass of 16. So if I draw my atom, silicon dioxide, well, I've got 1 silicon, and that is 28. I've got an oxygen there, which is 16, and an oxygen there, which is 16. So what is the relative formula mass of silicon dioxide? Well, I need to do 16 plus 28 plus 16. And let's get the calculator up so I don't mess it up. 16 times 2 plus 28. So the relative formula mass of this is going to be 60. That is the mass of one of these molecules. If you would like to have a go at that, that's a little bit of a challenge, then please do it, because that is GCSE, and if you can do it now, then you're going to be sorted for GCSE. So, everything that you've done, or the notes that you've written, could you take a photo of them or send them to me, please?